So, like I mentioned last time, the TIFIDIF doesn't actually tell the semantic meanings of the words. It simply tells us the count frequency of the words. So, whereas when we want to know what these words mean, like I want to know an apple is a fruit, a banana is something near to an apple, and so on, what the actual meaning of the words bring out, we will need something known as word embeddings. So it basically is a feature representation method such that we can represent our word in numbers or a vector or matrix. So we can see that for each word, we actually have, normally this would be in a much higher dimension vector, but for now, for this example, we'll just go with something simple and small. So maybe for each word that we have a lot of columns or attributes that assign to this feature, to this word. So like, let's say we have queen. We know that, of course, the royal attribute assigned to this queen word would be much higher, like as a compared to, let's say, knight. Of course, knight would hold certain royalty, but of course not as high as queen. And whereas in the combat ability, the queen would be much lower than the knight. So this is the gist idea of word embeddings. Basically, we just want to represent our word in a vector of numbers. Okay, so why would we want to use word embeddings? So it basically allows us to perform vector arithmetic. So basically we can do something like addition or subtraction. So we know that if the word king, since it is represents in numbers, like I said, if we add the numbers of the king with the numbers of the word women, we get queen. So because the values here would have been added or subtracted such that the values is near to the features value of the word queen. The same goes to, let's say, a shirt plus skirt, and then we would get something like dress. Okay, so another application is that we can find the similarity between the words, as since each features they would have a value assigned to them, so we can actually plot or visualize them out, and then we can see that there might be a cluster over here, and the words in that cluster might have similar meaning to them, such as the queen or princess or prince might have clustered in a cluster together. So let's see an example. So what I want to show here is a great GitHub post by Allison. I definitely recommend reading it to get a higher level of understanding of word vectors. But as you can see, this example given, we can see that for each, this example is we are trying to cluster the animals together to see how it would look like in a visualization. So for each animals that we have here, we assign in cuteness attribute and the size attribute to them. So let's say we know that the kitten is cute, but it is small or something like that. So when we actually plot this matrix out, we get this plot. So we can see that, oh, maybe hamster and puppy and kitten, they cluster together because they are all cute and small little animals, whereas like tarantula or lobster or chicken, they are smaller but they are not cute. So that's why they cluster over here. So this is what I meant when I said that we can actually calculate the similarity and cluster based on this the distances or the attributes that they have. So as you can see that we can actually get the distances between panda and capybara, or the distance between tarantula and elephant. So we might know that the differences between chicken and a puppy is as much as the differences between a mosquito and a hamster. So that's something that we can do with word vector. So I definitely recommend reading it. I will include this link in the description below. So another thing that I think that I should mention is Word2Vec, because this term is usually comes together with word embeddings, and I think it can get quite confusing, like what's the differences here. So basically Word2Vec is actually the neural network model used to construct the word embeddings that we mentioned just now. So the two different methods that we can use for Word2Vec is actually continuous bag of words and the skip-gram model. I'm not going to go into the details here right now, but basically how CBAL differs with skip-gram is that the CBAL, given multiple words, like, and then we predict the target word, like let's say if I give the word apple, eggs, and flower, maybe we would get apple pie. Whereas for the skip-gram, given a word, we predict the associated words, such as I give the word apple pie, and then the model would predict maybe desserts, apple, egg, flower, and so on. So that's the difference between Word2Vec and word embeddings. And that's it for this video, and I hope you like it. See you on the next one. Bye bye.